All right, so I'm going over 3.1, which is needed for the discussion this week. So this should be helpful for the discussion. I'll be showing everything you need to know in order to do the discussion and talk about some of the vocabulary and everything that you're going to be seeing for the other sections going forward. So 3.1 covers analyzing graphs of quadratic functions, writing quadratic functions in standard form and using the results to sketch the graphs, and finding minimum and maximum values of quadratic functions in real-life applications. So I do have a real-life application at the very end of this, but I'm going to go through most of the skills at the very beginning, and then I'm going to end with that real-life application. So we're going to just start with polynomial functions because that's what this chapter is all about. So in P.3, we did talk about polynomials, and that was an expression of the form shown below, where basically your exponents are whole numbers and they're all positive, and it just decreases in exponents. You don't have any variables in the denominator of anything, you don't have any square roots, no absolute values. The only thing on the variable is an exponent. So a polynomial function is just that set equal to f of x. That's what the difference between a polynomial expression and a polynomial function. The key is that the degree is equal to the highest exponent. So that is actually needed for the very first question on the assignment. The degree equals the highest exponent. And that was actually talked about in P.3. But I will repeat it here. The degree is the highest exponent. So for quadratic equations, the highest exponent is 2, so that means it's degree 2. And so the basic form is ax squared plus bx plus c. Our book, sometimes this is called general form. Most textbooks call this standard form. Our textbook is a little confusing when it comes to naming these because it actually calls multiple things standard form. But generally, standard form of any type of function is where everything is multiplied out. So ax squared plus bx plus c, we don't have any multiplication. That's the standard form. Everything is on one side, essentially. So when you graph a quadratic function, you get a parabola. So it's a U, basically. There are a lot of things in real life that are U's, like the St. Louis Arch is a parabola. So there are two basic shapes that are graphed here. One where it opens upward and one where it opens downward. And that is all based off of the leading coefficient. So we have ax squared plus bx plus c. So the leading coefficient is a. So if your a, the number in front of the x squared is positive, it opens up towards positive y. And if your a is negative, then it's going to open down towards the negative numbers. So the value in front of the x squared tells you whether it opens up or down. The line, basically the line of symmetry, that is called the axis of symmetry. So the line that you can draw where it forms a mirror image. So I'm going to that is called the axis of symmetry because it's symmetric on either, oops, I wrote symmetric. The axis of symmetry. So it's right in the middle. That is where we are symmetric on either side of that line. So that line, the red dashed line, is called the axis of symmetry. And the vertex is the highest or the lowest point, the maximum or the minimum. So the vertex is basically where it changes direction. So if it opens up, our vertex is a minimum. And if it opens down, our vertex is a maximum. So the vertex is an ordered pair, an x value and a y value, and it's either the highest point or the lowest point in its area. So the relative max or min, which is language that we talked about last week with functions. So you want to be able to recognize the graph of a function, and if we go back to the parent functions, this was an x squared or a squaring function. So because a lot of people struggle with transformations, and it is important to understand transformations, I figured I'd spend some time on transformation of a quadratic function. So there is another way that you can write a quadratic equation, and that is in this form that I'm highlighting, where it's a and then in parentheses x minus h, then that's squared plus k. So that is called vertex form. Most textbooks call it vertex form. The internet, most things you find on the internet call it vertex form. Vertex form is the standard name for it. However, our textbook calls this standard form, and it calls the prior form, the one on the previous slide, it calls the equation here standard form. It calls them both standard form, which is very confusing. I always refer to this as vertex form because that's the most common use, and it's called vertex form because the h and the k are the ordered pairs for the vertex. So if it's in that form, you have your vertex immediately just reading it off of the equation, and that makes it really easy to graph. I actually have a link to this website here. This is actually a great resource. So I'm going to open this up because it actually talks about vertex form. So I'm going to bring that up on the screen. Whoops, let me bring that up again. So calls vertex form, you can see the form right here, and it does also go into the things. It says different textbooks have different interpretations of the reference standard form of a quadratic function. Some say ax squared plus bx plus c is standard forms. Others say a times x minus h squared plus k is standard form. Our textbook does both. So this is just a reference that's talking about it, and it's talking about vertex form. And so it tells you the axis of symmetry, talks about the shifts, which are the transformations, it has some examples, and it shows you how to convert from the standard form to vertex form, and it shows you different ways to do it, different methods. So I think this is, and even like tips for graphing it. So I think this is a really great resource to use. So I have that linked here. So I would recommend, actually they have tons of other things at this MathBits notebook. It's a pretty great website. So that's just a resource that I've linked there. So if we, so going back to the transformations, when something is in vertex form, that's when we talk about the transformations. So the value A, that tells you whether it's stretching or shrinking. And it also tells you whether it's opening up or down, which if it's negative, it's a reflection. That's one of the transformations. The value that's subtracted from x, that tells you whether you shift left or right. If it's x minus a number, you're shifting to the right. If it's x plus a number, you're shifting to the left. You do the opposite. So x minus a number shifts right. If it says x plus a number, you're shifting left. And then we have plus k. So if it's a plus and then let's say just a positive number there, that shifts up. And then if it's minus a number, it shifts down. So when you have a quadratic, you have these three basic transformations. You have a stretch or a shrink, you have a horizontal shift left or right, and then you have a vertical shift up and down. So those are the three basic transformations, and when your equation is in vertex form, you can figure out those transformations immediately from the equation. You don't have to do any math, you can just read them off of the equation because the equation will tell you. So before I start going into examples, are there any questions? Thank you, Drew. If you guys have questions, just let me know. Okay. So I just have a series of examples from here because that's really the best way to learn. I do have another slide where I go into a little more detail, but I wanted to start with transformations because that is where everybody struggles. So we have an equation here. This is in vertex form. Identify the transformations of f of x equals -1/2. Then we have in parentheses x minus 2 squared, then plus 1. So the -1/2 there. First, that negative means we have a reflection. So when we talk about transformations, we don't really have to talk about if it opens up or down, but just to hark back to the picture or our graphs, because that's negative, the graph would be upside down. So it'd be a frown, basically. And then 1/2. If your number is less than 1, if it's between 0 and 1, like if you look at the absolute value, that means it's a shrink. So what happens is that it kind of widens out because it kind of pushes it flatter. So if we were to graph this, you would have your basic equation, and then it's going to flatten out. So it's not going to be as steep. So that's what the -1/2 does. It reflects and then it shrinks it down. Now the -2 there, that is subtraction, so we do the opposite. So this is going to be a shift to the right towards the positive value. So this shifts right by 2. So this is a horizontal shift to the right of 2 units. That's what this transformation means. And then this +1 here, and I'll circle it so I can make sure that that's the k, that's what we're adding vertically. So because it's positive, we're shifting up. So this shifts up by 1. So those are the transformations. So our transformations are we have a reflection, we have a shrink, that's a terrible N, a shrink of 1/2. We have a horizontal shift right 2. And we have a vertical shift up 1. So we have 4 transformations. We have the negative, we have the value in front, the 1/2, we have a horizontal shift, and then we have a vertical shift. So I'm going to bring up Desmos, and so I can show you these transformations. This is zoomed in quite a bit. Okay, so our parent function for a quadratic is always x squared. So I'm going to just write f of x equals x squared. So this is what the parent function looks like. So our function, I'm going to just put, oh, I didn't mean to have caps. I'll call g of x, but it doesn't matter. So I have a -1/2, and then parenthesis x minus 2 squared plus 1. So you can see the first thing was that negative. The negative makes it upside down. Then we have the shrink of 1/2, which means that it's sort of flatter. So if you try to compare, and it might be easier if I just do these transformations one at a time. So let's pretend all we have is that 1/2. So you can see that it's not as steep, it's a little wider. So that's what that 1/2 does. And that negative made it upside down. Then we have a horizontal shift 2 to the right. So that x minus 2, you can see when I put that in, it moves to the right by 2 places. And then when I add 1 to it, it moves up 1 place. So that's what we mean by transformations. We're taking what we originally had, and then we're doing things to it to move it around, put it upside down, kind of transform it into a different shape or in a different area of the graph. So our parent function is in red, and then the blue is the transformed function. Do you guys have any questions on the transformations, and does this help you on that concept? It's extremely helpful. Good, good. It's one of those things that I think is a lot easier to see graphically when you're trying to understand what a transformation means. Most of the time with the questions on the quiz about transformations, you can just graph it. So as long as you know what the parent function is, that kind of gives you a good visual there. Actually, I think Desmos, does it have anything on functions here? They actually have things on transformations. They have different examples. So they have one on translating, which moves it left and right and up and down. Scaling, that's the stretch and the shrink. Inverses, we did talk about inverses. So there's actually some examples here. Let me just open up one of these. And it just shows you if I move k, that's the up and down. And then if I move that x or that h value, you can see that it moves left and right. So these are really cool, just so you can see the different shapes and how they get changed. Okay, so now I want to focus on the maximum and minimum values and the vertex, because this is helpful for your discussion, and this is actually one of the most common things that you do with equations, is to figure out what the vertex is for the quadratics. So what we had in the previous slide, that is in vertex form, and I'm going to just reiterate that by writing this down. So this example 1 is in vertex form. This example is generally standard form. So vertex form tells you the vertex, but standard form does not. So we actually have formulas to figure those out. So, and those are that's going to come in handy. So the h value, the formula is negative b over 2a. And then the k value, it comes from plugging in that h value into the function to find the matching y. So to find k, you have to plug in your h, and then that will give you the k value. And you have to use that with your standard form. On that other, this is the little shortcut. So if I go back to this link that I had shared, normally you would do completing the square, but completing the square, I know that you guys suffered through it. It's really annoying. So you can use vertex form, use these shortcuts instead. And you can see just by completing the square has lots more steps than using the vertex form to get it in the right form. So definitely vertex form is going to come in handy. It'll make your life so much easier than trying to do completing the square. So I'm going to just go through several examples here. And these are worded just like the book words it, because I do want to be consistent with the textbook, because that's what you're going to see on the quizzes as well. So, oops, I'm in the highlight. I did not mean to be in the highlight. So the book says to put this in standard form, which they mean vertex form. That's what they mean when they say that, because it's already multiplied out, so the only other possibility is vertex. This is why I don't like the book that it uses the same word for both of them, because it's confusing. So we're going to put this in vertex form, and then we're going to identify the vertex, the axis of symmetry, and the x-intercepts. And then I'm also going to put this on a graph so you can verify. So we're going to use the formulas that I had. So the vertex is an ordered pair h comma k. And so we need to figure out what h is. We need to figure out what k is. So h is equal to negative b over 2a. Now our function that we have is g of x equals x squared minus 8x, and then I'm going to write plus 0 just to make sure we have that there. So just like the quadratic formula, a, b, and c are the same thing. So because we don't have a number in front of the x squared, a is equal to 1. In front of the x is b, so b is negative 8. And then c is 0 in this case. But we don't need to know c for the vertex. So the a, the b, and the c are the same thing that we use for the quadratic formula. And you can see that the vertex, that negative b over 2a, is just like the quadratic formula, because the quadratic formula has a negative b and it's over 2a. So it actually is related to the quadratic formula. So b here is negative 8. So I have the negative, and then I have to replace b. So if I have a negative b, and b is already negative, I'm going to end up with a positive. And then 2 times a, so a is 1. So that's going to be 2 times 1. So this will be 8 over 2, which is 4. Now that we have found h, and this is the x value, so the h is an x value, now we need to find k. And k is, in this case, our function is g. So we plug in h in for g. So we're going to plug, sorry, I said g. We're plugging h in for x. So where we have x squared, we are now going to have h squared. So that's going to be 4 squared minus 8 times 4, and then we don't have to do the plus 0. So 4 squared is 16. 8 times 4 is 32. So 16 minus 32 is negative 16. So what we have found so far is that our vertex is an ordered pair, the h value 4, and then k is the y value. So the vertex is at 4, negative 16. The axis of symmetry is always x equals h. So once you find your h value, you also have the axis of symmetry. So that's going to be x equals 4. The x-intercepts come from setting the equation equal to 0. So, but first I'm going to put this in standard form because we have all the information we need to do that. So, if I go back to my colors here, it's a times x minus h squared plus k. We know a, we know h, we know k. So, our standard form, or vertex form, is g of x equals 1. We don't even really need to write that 1, but we can put it there. X minus the h value, which is 4, squared, then plus the k value. Now our k is negative, so we can just write minus 16. So that's going to be standard form. And the last thing we need to do are the x-intercepts. And I'm going to put that in the little box there, trying to color code so that things don't get too confusing. So the x-intercepts, and this is something that we do have to do in the discussion. You need to find your x-intercepts, and you also need to define the vertex. So I've demonstrated the vertex. Now the x-intercepts, you set your equation equal to 0. So we have x squared minus 8x equal to 0. Now, because we don't have a c value, I don't have to use the quadratic formula. I can actually just factor, because on the left I can factor out an x. So that would leave me with another x. Then I remove the x and I get minus 8 there. So I've just factored the left side. Then you set each side equal to 0, or each factor equal to 0. So I have x equals 0 and x minus 8 equals 0, which gives me one of my x-intercepts as x equals 0, and the other one as being x equals 8. So now I have my equation in standard form. I have found the vertex, I have found the axis of symmetry, and I have found the x-intercepts. Before I throw a graph up on here, do you guys have any questions on the work? Okay, so let me throw my graph up then. I will just, let's just do a new blank graph. Okay, so I'm going to just graph the original one. G of x equals x squared minus 8x. And then I'm going to just kind of zoom out so that you can see that. All right. Now, just to verify that we put this in vertex form correctly, I'll just use a different letter here so I don't get confused. F of x, we had 1 times x minus 4 squared minus 16. So you can verify that you did it correctly because now the graphs are on top of each other. So that means that those are the same, it's the same equation, we just basically rewrote it. And so the vertex is the lowest point. When you click on the graph, what's nice about Desmos is that it tells you these. So the vertex, when I hover over it, it says 4, negative 16. So we got our vertex correct. And I can even graph the axis of symmetry, and you can see that that's the middle point. It's x equals 4 gives you the middle between the two parts of the graph. And then we can even verify our x-intercepts. Again, I click on the graph and I hover. It tells me that x equals 0 is one of them. And then the other one we got was 8, and I hover over it, and you can see we have 8, 0. So those, I got my x-intercepts correct. I got my vertex correct, and the vertex in this case is the minimum. It's the smallest y value, essentially. That's going to be the small point on the graph, and then it goes up. So you guys have questions how that equation then translates to the graph, and how our values that we solve for match what's on the graph? Perfect. Okay. So I have a second one here, and I picked this one because the a value is not 1, and because it has a c value, which means that we will have to use the quadratic formula. So this one will be closer to what you have to do in the discussion, because for the discussion you will have to use the quadratic formula. So I know that I'm going to be running out of room here, so I'm going to have to try to conserve my space. But the first thing I'm going to do is to identify my a, b, and c. So a is 2, b is negative 1, and c is equal to 1. Now I'm actually going to do the x-intercept first because that's going to take the longest, and I just want to make sure that I have enough room. So I'm going to just put this to the right here. So to do the x-intercepts, you have to set your equation equal to 0. And then you would factor if possible. This one might be factorable, but I'm just going to go straight to the quadratic formula because we know that works. So the quadratic formula, and actually I'm going to write it up here. Let me do this in a different color. So our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you can see that b minus b over 2a part that shows up again in the vertex. So x equals negative, and then our b is negative again. So we're going to have a negative, negative 1 plus or minus negative 1 squared minus 4 times a, which is 2, and c, which is 1. And then we have 2 times a, which is 2. So I'm just plugging the numbers in for a, b, and c. And now I need to simplify. So the negative, negative 1, that's just going to be a positive 1. And then negative 1 squared is a positive 1. And then I have minus 4 times 2 times 1. So that's going to give me negative 8. And then in the denominator, 2 times 2 is 4. So I simplify inside the square root. 1 minus 8, I'm going to get a negative 7, which means I'm going to get complex values. And as soon as you get complex values, you can't graph them. So that negative inside the square root tells us that there are no x-intercepts. So it is possible to have no x-intercepts. So if you get a negative inside your square root, that means it does not cross the x-axis at all. And so you don't need to go find out what the actual number is, because it's not an x-intercept, and it told us to find the x-intercepts. However, we do have zeros. This problem doesn't ask for the zeros, but we would have 2 zeros. And if it asks for the zeros, you would have to finish the problem and figure out what the imaginary numbers were. But we don't have to do that in this case. So I got the x-intercepts out of the way. That's usually the one that takes the most work. So that's probably the easiest one to do. Just do that first, get that work out, and then go back. So now let's go back and do the vertex. And so I'm going to just, I don't want to get confused with my red. So we want to find the vertex, and I'm going to write the formula up there again. So it's negative b over 2a for your h, and then you plug in h to find k. So h is negative b over 2a. So I have a negative, negative 1. And if you notice, we've actually calculated all that out from the quadratic formula already. So that's another reason why it actually is easier to do quadratic first, because you have those numbers already. You already found negative b and 2a. And actually, let me color code those with my highlighter. So the negative b over 2a, that's going to be 1 and 4, because we already found those. So I can even just go straight to there once I've done the quadratic formula, because I've done all that work. So negative b, that came out to 1, and 2a comes out to 4. So our vertex here is 1/4. Now we need to find k, which is plugging in that h value into the function. So I'm plugging 1/4 into our function. So that's 2 times 1/4 squared minus 1/4 plus 1. So 1/4 squared, you square the top and the bottom, so that's going to be 1/16 minus 1/4 plus 1. So it actually, at this point, I would just use a calculator to do that because there's no reason that you guys need to work through all the fraction stuff by hand. Just use a calculator to get that. I'm worried more important, or I think what is more important is actually understanding what you're getting and the vocabulary. Desmos can actually even do that for you. So I'm going to put Desmos back up again. If you really want to do it, you can even just do it straight into the graphing. So 2 times 1/16, and I have like a, there we go. Then it was minus 1/4 plus 1. The problem is that Desmos doesn't give it as a fraction. So that's the only downside. But see this little button that I clicked here? So you can see that it actually looks like a little fraction here. If I click that, it gives me the fraction version. So our value here is 7/8. So let's just use Desmos to do that for us so that we don't have to mess up with your fractions. So our vertex is 1/4 and 7/8. And now that we have the vertex, that means we have everything we need to put it in standard form. So standard form, or vertex form, f of x equals, you start with your a value, 2, and then in parentheses, x minus your h value squared plus your k value. So I'm going to write that. It's always good to rewrite the equations over and over again so that you remember and it helps you memorize what they are. So it's a times x minus h squared plus k. So I just need to plug in those values. And then our axis of symmetry is just the x value, the h, what h is. So our axis of symmetry is x equals 1/4. So let's see, I go back to the question, make sure I've done everything. Put it in standard form, I found the vertex, I found the axis of symmetry, and I found that there are no x-intercepts. And I can confirm all of this with graphing. Before I do so, do you guys have any questions? All right. So just for good measure, let me pull up the graph. So it is 2 times x minus 1/4 squared plus 7/8. So I'm going to just turn that old one off. And so you can see there, we said that there was no x-intercepts, and you can see that it does not cross the x-axis at all. So that's why we got an imaginary number, because it doesn't actually cross the x-axis. So you can get a confirmation there, and then you can zoom in, and we can see what the y-intercept is, but that's different from the vertex, and it gives it to us in fraction form there. But you can just kind of verify your numbers, which is a great policy when you're doing things on the quiz, because you can always use a graph to verify what you're doing, especially for everything we're doing going forward. All right. Next example, and this is where this time you're given the graph and now you are writing the equation. And it says to write the standard form of the quadratic function whose graph is the parabola shown. And there are two different ways to do this. You can do this based off of the vertex, or you can do it off of the intercepts. And so that's why I chose this one, because there's two different ways that you can do it. So first off, and especially because it says standard form, it doesn't matter which form you use. And then standard is ax squared plus bx plus c. And if you want to do it based off of intercepts, then you have a times x minus intercept 1. I'll just call it I1, x minus I2. So you have your intercepts, and then you can multiply them out, and then you need to figure out what a is. And that's the hard part on something like this, is that we don't know what a is. In our graph, we're given the vertex. We know h and k, and we know the intercepts. So it's our job to figure out what a is, and we can do either one. So I'm going to do it two ways, and you should get the same answer both ways. But I'm going to start with the vertex, because when it says standard form, that could be potentially what the question is asking about. So I'm going to first plug in what I know. And I'm going to just use y and x. So I know y is equal to a. I don't know what a is, but I know they've given me my vertex here. H is -2, k is 2. So x minus h. If your h is already negative, that means we're adding. So now that's going to be x plus 2, and then my k is 2. So I have y equals a, and then in parentheses, x plus 2 squared plus 2. Now, to find out what a is, I need to plug in one of the other values. It doesn't matter if I use -3, 0 or -1, 0. I will get the same answer. I'm going to use -1, 0 because working with -1 is a lot easier than -3. So you replace, this is your x and a y value. So I'm going to have y is 0, and then I'm going to replace x with -1. And this will give me an equation that I can solve for a. So I have 0 equals a, and then -1 plus 2 is 1, so that's 1 squared plus 2. So 1 squared is 1, so that's just a times 1 plus 2. So we have 0 equals a plus 2. So you subtract 2 from both sides, you get a is equal to -2. And so now we have our equation in vertex form, because now I know what a is. So it's -2 parenthesis x plus 2 squared plus 2. A lot of 2's in this one. Now I'm going to do it using the intercepts. And whichever method you use depends on what values they give you. Later, and actually the intercepts version is helpful for the assignment, because there is a part in the assignment where you need to write the equation of the parabola, and it's not a parabola, it's a polynomial. You have a degree of 4, but you do it based off of your intercepts or your zeros. So this method in purple is going to be sort of similar what you have to do on the assignment. So I know my intercepts. One of them is -3, 0. So the first value is -3. And then the second one is -1. So those are my i's, basically the intercepts values. There's the x values. So I have y equals a times x minus the -3, but that becomes a +3. And then x minus the -1, which becomes a +1. So you're just taking the x values of the vertex, and then you're basically flipping the signs, and you're just putting them in, kind of undoing the factoring and the solving, basically. Or I said the x values of the vertex, I meant the zeros or the intercepts. Now you need to plug in a point again, but you need to plug in a different point than the intercept. So I have to plug in the vertex in this case. If I plug in one of the other ones, it's not going to give me any new information because I already used those 2 points. So if I use the vertex, that's my y value is 2. My x value is -2. So I'm going to have -2 in for x. And now I need to simplify by solving for a. So -2 plus 3 is 1. -2 plus 1 is -1. So that gives me 2 is equal to -1a. And then you divide both sides by -2. You get a is equal to -2. So you get the same value for a, which is good because you're supposed to. Then we could write this as f of x equals -2 times x plus 3, x plus 1. And then you could multiply it out. So if I FOIL, I got x squared, 3x plus 1x is 4x, 3 times 1 is 3. So FOIL would give me x squared plus 4x plus 3, and then I could multiply the -2 through to get the other version, the other standard form. But these will graph the same exact equation. They're just different forms of the equation. And you can get the same answer depending on which method you use to find the equation. So it's up to you. Use either one depending on what information you have. If you see a graph and you're not given the vertex, but you're given the intercepts, then do the intercept method. You don't have to use the vertex to plug in. You can use any point to plug in. Like I could have plugged in the y-intercept here, which looks like it is at 0, -6. If you're given the vertex, though, I would definitely use that form and then another point. So there are any questions on how to get an equation based off of the graph? You get it, but you don't like it. Well, you only have to do it once on the assignment, and I think you only have to do it once on the quiz and once on the final. So as long as you know how to do it, you only really need to do it 3 times. So if that makes you feel any better, I don't know if it does. All right. Example 5 here. Write the standard form of the quadratic function whose graph is a parabola with vertex 2, 3 and passes through 0, 2. So this time we're not given the graph, but we're given 2 points. So they're giving you the vertex. This is where I would use the vertex form. This is that sort of situation. So again, vertex form, a times x minus h squared plus k. So we will use vertex form. So I have f of x, or I can just use y because it doesn't say it has to be f. So y equals a x minus, and then I'm going to use my vertex. So h is 2, and then k is 3. So I'm going to plug that in because they're giving me my vertex, 2 and 3. Now they're giving us a point. They're actually giving us the y-intercept, 0 and 2. So I'm going to plug that in. So y is 2, and x is 0. So I have 2 equals a times 0 minus 2 squared plus 3. So now I need to solve for a. So I have 2 equals a. 0 minus 2 is -2. 2 equals a. Now I need to square the -2, which is positive 4. So I have 2 equals 4a plus 3. So I'm going to subtract 3 from both sides. 2 minus 3 is -1 equals 4a. And then I divide both sides by 4, so I get -1/4 as a. Whoops, I should say equal a. But once I've done that, now I have my function. F of x equals a, which is -1/4, x minus 2 squared plus 3. So it's really not, it's not really like it's a lot of work. It's just making sure you know what to plug in where. So I'm going to actually just highlight here. So your vertex, that is going here. And then when it passes through some other point, those get plugged in for your y and your x so that you can solve for a. But once you have everything in there, then it's just kind of plug and chug. Just follow the order of operations and solve. Any questions? Okay. So, I see, Joanna, you're typing. Is that a question or just a no? You're good. Okay. Last one. I know that this is a long one. We're almost at an hour. But this is my last example, and this is the word problem one. So I picked this one because while it's not baseball, it's another sport one. And it asks for the maximum height. And in this case, it asks for how long is the punt, but that's analogous to saying when does it hit the ground again? Because it will hit the ground when the punt, when the punt is done, it hits the ground. We're looking for that distance there. In this case, the x is the horizontal distance. In our discussion, it's the vertical distance. But the steps are basically the same. So we have a path of a punted football modeled by this equation. So that's what we're going to basically look something like that. This is our horizontal distance. And actually, I could draw a really bad football there. And we've got a person kicking. That was a really bad. That's supposed to be the leg kicking the football there. A really bad drawing, but they're punting the football, and then it's going to travel a parabola, basically. So, first question, how high is the ball when it is punted? That is the y-intercept. And that is where your x is equal to 0. Oops. So I'm going to do part A over here. So f of 0 is -16 for 2025 times 0 squared plus 9/5 times 0 plus 1.5. So anything times 0 is 0, so f of 0 is just equal to 1.5. And so they're telling us the height is in feet. So it is 1.5 feet high. That's how high the kick is. So that's, the football player, he holds it up. He's holding it 1.5 feet off the ground, and then he kicks it. Next is, what is the maximum height of the punt? So that is the vertex, but we specifically want k, because that is the y value. That is the maximum height. So in your discussion, when it asks for the maximum height, we're looking for the k value of the vertex. So we need to use the vertex form where your h is negative b over 2a, and then your k is going to be plugging that in. Now, in this case, we've got some really nasty things to work with. We've got these fractions, and they're gross. So b is 9/5, and we have this really gross value for a. So negative b, so this is negative 9/5 over 2 times negative 16 over 2025. So I would just use a calculator to make that easy. So I'm going to go back to Desmos since I have that available. So when I'm trying to put this in Desmos, I'm actually going to, let's see, do I have a fraction? I don't have the fraction button here. So I'm going to try to, first, at the top of our fraction is negative 9/5. So I'm going to just put that in parentheses, divide it. So now I'm creating my fraction. And then it's 2 times our a value, which is negative 16 over 2025. And so because our equation is given in fractions, we want our final answer in fractions. On the discussion, use decimals. Don't bother using, actually, because we have decimals in, actually it says plus 1.5. So let's use the decimal version. Let's not mess with these fractions. So we will use the decimal version. So the x value is 113.90625. So let's just say that's 113.9. So this is approximate, so I'm going to make those wavy. 113.9. Now I need to find k by plugging in that value. So I have negative 16 2025 times 113.9 squared. I should have moved over. Plus 9/5 times 113.9, then plus 1.5. And again, because this is going to be nasty, I'm going to just put this in a calculator. So what's really nice about Desmos is I'm actually, let's just erase everything that I have so far. I can put in the equation that they're giving us. So we have negative 16 over 25 x squared plus 9/5x plus 1.5. Okay. I can find my k value, and I'm going to, this is the nice thing about Desmos, is I can use this function notation, 113.9. And it is, because I gave it the equation, it's plugging it in for me, so I know that it's going to be 104, or about 104. So our maximum height is the k value. So this punt was about 104 feet high for the maximum height. Now the last part is how long is the punt? Now that is this distance. It is the distance between where it starts and where it hits the ground. So it's the distance between 0 and the x-intercept. So to find the x-intercept, for here we would have to use the quadratic formula. And I'm actually, again, I'm going to just use decimals so that I can do that for me, and it's going to make our life so much easier. So I'm going to start with trying to type. I'm going to just artificially create this fraction here. Okay. So we have negative b. b is this 9/5. So that's 9/5. And then we have our plus or minus. So I'm going to have to enter this twice. So I'm going to have to do it with the plus and then one with the minus. So I'll just do the plus and then change it to the minus. Now I have my square root. So it's b squared. So I'm going to take that b value again. 9/5 squared minus 4 times a. So I'm going to just copy and paste times c, which is 1.5. And then our denominator is 2 times a. So I'm going to have to copy a again. Okay. So our one x-intercept is negative 0.83. But that's not the one we want, because we want on the other side. I'm going to zoom out the graph here, which is going to be, so we want this x-intercept on the right, because that's when it's hitting the ground. So I'm going to just change this plus to a minus. And it's hitting the ground at 228.64 feet. So it says, how long is the punt? We have two x-intercepts. We want that distance from 0, which actually is already compared to 0. So that is how long the punt is. The punt goes about 229 feet because it's already basically counting from 0. And we can verify that on the graph. So I'm going to just go back here. And then for C, I'm going to just write, we're going to do the quadratic formula. And then we get about, what was it? 228.6 feet. And so that's how we can use this quadratic formula to figure out information about a football. You can find out how high, where it's hit, you could find out the maximum height, and then you can find out how long it goes. Do you guys have questions on this example, or even just how to use the technology to help make your calculations easier? Okay. I'm going to, you will watch it, yeah. I would watch it while you're doing the calculations so that you can follow it step by step. And I know I typed this whole quadratic formula thing in all at once, but here's what you can do to make your life easier for the discussion. So our discussion, we have a function f of x equals negative 16. It's t, but we can use x, so x squared plus, we don't know our velocity, so I'm going to just put v naught x plus h naught. That's our basic form. You were finding your initial velocity, so I can just say, okay, I think 146 was something right there. And then you're finding your height. So I think somebody said the strike zone is about at 1.5, maybe it's 2 feet, I don't know. Let's just make that 2. So now I have my function. I've just put in the number so that I can have this thing graphed. Okay. I'm going to change my x-axis because let's go from negative 10 to 10. Okay. I just made up these values for the velocity and the height. You'll have to find it off of the baseball stuff. But we can even say vertex equals, and you can say, let's say, I can even just do h. Well, first, let's do a. So in our formula, our a is negative 16. So I'm going to just label a as negative 16. The b value is equal to our velocity. So I can just say b is equal to velocity. And our c value is equal to the height. So I'm going to just say our c equals our height. So now I've got a, b, and c labeled here. So to find my vertex, I can say h equals, and I can put in the formula, negative b over 2a. And because I told it what a, b, and c is, it can give us the number right here. So it's telling us, okay, this is in time, so after about 4.5 seconds, it's at the maximum height. Now that I've labeled h, I can find k by just using my formula, k equals f of h. And now I have the maximum height, which is 335 feet. Now I want to know when it hits the ground, so I can even type in the quadratic formula here because I labeled my a, b, and c. So I'm going to create my fraction, negative b, and I'm going to use plus, and then I'm going to copy it to the other one. B squared minus 4ac for 2a. And then it's giving me one value for my quadratic formula. And then I can change that to a minus to get the other one when it hits the ground, which is after about 9 seconds. So this will make your discussions much easier because instead of trying to type all of the math, you can set it up in Desmos. As long as you label everything, it will calculate it out for you. Now, if you use this method, what I would like you to do is take a screenshot of this so you can put it in your discussion so that we can verify this is what you did, so you can show this is how I got my answers. You know, I typed in, I picked out my values, I plugged it into Desmos, and this is how I found them. But hopefully this will help you on the discussion because there is a lot of calculations and they do involve decimals. This is also another way to check your work. So I'm going to actually see if I can zoom in so that way when you rewatch this video, you have these bigger and you can pause. So I have my initial velocity in feet per second, my initial height. This is the equation we're given. I told Desmos what my a value is, what the b value is, and what the c value is. I plugged in the formula for the first value of the vertex. I plugged in the formula for the second value of the vertex. And then I plugged in the quadratic formula with the first with the plus. And I can even copy that and do it again with the minus. And you can get both values. So Desmos is a wonderful thing that will make your life so much easier, and this will make your discussion work so much easier as well. So you just have to make sure you put a screenshot and then explain, you know, what you're doing here. So hopefully that will be helpful. Do you guys have any questions for me on anything? Let's just say anything at all. Do you have questions? Not right now. All right. If you do, of course, you can email me or give me a call. I'm probably going to post this tomorrow morning because it might take a while to process. The one from last night took several hours, so I don't know how long it's going to take. So I'll probably post this tomorrow, and then that way you'll have an opportunity to watch it again and work through it with the discussion and work through some of the practice problems as well. So thank you guys so much for joining and for sticking through the whole time. I really appreciate it. So because I have my tablet on the floor, if I stop sharing, all you're going to see is my ceiling. I need to get a separate webcam. So I'm not going to stop sharing so you don't have to stare at my ceiling. But thank you guys so much. I'm going to sign off. I hope you guys have a great weekend. Yes, and you definitely enjoy your evening. Don't forget Grantham's closed on Monday for Veterans Day. I'll probably be on a remind. So You know, if you send me messages through Remind, I'll be getting those, and I can respond. Those don't take too long. So, all right.